Prairie Sun Timber, a Build original series, is brought to you by Proseco, Interlux Windows, and TimberTech.
I'm Travis Brungardt with Catalyst Construction and also with the Build Show, and we were thrilled to work with Proseco on our Prairie Sun Timber series here in Kansas City. Now, Proseco is a national company that provides all sorts of solutions for building durability with cutting-edge building science. They're managing water, air, and vapor control with their families of products, and on this particular project, they were a prerequisite for us. This is a SIPS home, meaning structurally insulated panels, basically an OSB skin over foam for a performance function. But OSB is notoriously prone to delamination when it takes on moisture, and that's where Proseco came in to save the day. They offer a family of products to address every joint with their joint and seam filler. So between these panels, I can fill that gap with joint and seam filler, a little more fibrous. Then I can treat over the top of that with their Fast Flash product, and I do every nail penetration with that so that we have a perfect substrate to then apply their Cat 5 monolithic coating. Now that Cat 5 monolithic coating acts like a house wrap or an integral WRB to completely encapsulate the entire substrate. So from foundation up over the roof and down to the other side on the foundation, we're completely encapsulated in the Proseco family of products here. And that's how we're keeping our blower door score low with great air tightness, but keeping all of our water out. So it's been a real pleasure to work with Proseco on this project, and we'll continue to do so. Welcome to the Build Show Prairie Sun Timber series. I'm Travis Brungardt. I'm excited to invite you along as we tour what will be a start to finish process on a very unique home here in Platte County, Missouri. What we're talking about is a timber framed structure overlaid with a SIPS structurally insulated panel system wrapped in a high performance coating to manage air and water control, and then detailed out with all the high performance stuff that you've come to expect from all the Build Show contributors, but certainly from us, where we want to building science the heck out of everything we touch. We're going to provide you a look in at what makes this high performance system work so well, how important the design elements and the planning of that system is from start to finish, so that it can all seamlessly integrate to perform at the level that our client desires, and frankly, that we hold ourselves to providing for all of our clients. It's not a system that we've built before, and so there's some new partnerships that have to be navigated, and it's also a unique system in terms of the structural component being the skin. As an electrician, that's a challenge for me, not having walls to run wires in. There are some things that are going to be a little bit different. So we're excited to have you along to check out this Prairie Sun Timber episodic series, and we look forward to showing you just how this all comes together. We're coming to you from the walkout. Now, we want to talk about all things below grade in this episode, and we want to do a really thorough job of explaining why we made the choices that we did and give you some perspective on what might help you out on your project. So obviously you can see we have a great deal of 3/4 crushed stone behind us. That's going to be infilled at this walkout wall so that we can manage our water at this location and not worry about settling, because obviously anytime you do excavation, your overdig is where you have settling occur. And we're gonna have a patio back here for this big, beautiful walkout. So we're gonna start with a heck of a lot more crushed stone, and underneath we're gonna have a continuous drain tile. That's the corrugated pipe that everybody uses around the exterior. We've used solid PVC in some of our assemblies, and we will have some sections of solid PVC, but this is a very low risk site. We're elevated, we have positive drainage on all sides. This is frankly the weakest point, and we're still gonna add a sump just because the client was like, I like a sump, let's have it just as a backup. So below grade strategy, obviously we always wanna get water down and away. This is an easy site for us. We don't have a high water table or a sloping condition that drains to our site. But after we place the drain tile and then place all of the crushed stone around it to facilitate that drainage, then we're going to go ahead and place our Rockwool under slab insulation. So we'll get our ground rough plumbing in. There's a regular editorial content on that you can watch on the build show of Joe and I laying that out. But it's a typical ground rough plumbing assembly. Nothing special there. We are on septic here on a rural site where we're on 90 some acres. The client's not tied to city sewer. So we've got septic on site that we'll be tying our sewer piping into. And then what we'll need to do from that point is place crushed stone level with the top of footing on the entire interior of our foundation so that we can then place our Rockwool comfort board. And that's our interior under slab insulation. And that's a really critical step because if you think about it, the ground is about 55 degrees year round. At 3 feet below grade where we're at our frost line, that never changes. But then in the winter, when it's 0 degrees, that earth will be 0 degrees. So when we talk about conduction, moving energy, we're losing heat through the wall to that cold ground. And we want to make sure that everywhere that we're connected to the ground, like at this walkout, we have a thermal break. So that 3 inches of comfort board under the slab will also be broken at the edge of foundation wall and then tied into a continuous interior foundation insulation. I want to talk about the exterior of the wall. You can see here we've got a spray applied coating. There are certain site conditions that would lead me to a more robust coating, like a highly elastomeric coating that would be more of a waterproofing. This is a standard damp proofing product, spray applied, and we're basically applying that sort of a code minimum of approach because we're going to cover it with something much more robust. On this project, we're utilizing the PolyGuard Polyflow 10 drainage board. That's a dimple mat that has a fabric facer that keeps the soils from integrating into that drainage board. So you have a termination bar at the top to keep any water or soil from moving into the drainage board, and it allows for any hydrostatic pressure to flow freely to the bottom and into that drain tile to be evacuated. So that's our below grade drainage strategy using the PolyGuard Polyflow 10 and then our typical drain tile with damp proofing. So we've managed for water. I've already talked about how we're going to manage for our thermal barrier, but on top of that Rockwool comfort board, we're going to apply our Stego product. We're big fans of Stego here at Build Show, not just because it's more robust than your typical minimum 6 mil poly, but because they have all those different solutions and a system that really works together. So on top of our comfort board, we're going to apply a Stego Home 10 mil product. We could use the 15 mil if we had a very large project that had a lot of structural steel where the guys were going to be, I don't want to say sloppy, but a lot more movement and a lot more friction to challenge the thickness of that product. The 10 mil is adequate for this project, and that's what we've chosen. But we stick with Stego because they supply all the solutions to make that system work together. We're going to be using the Stego tack tape, basically pulling our Stego tight to the bottom corner where the foundation and the footing meet, and we'll apply the Stego tight to that location at the top of our comfort board. Then we can use the Stego tape to make all of our seams water and vapor tight, as well as air, although the concrete's really going to do a fine job on the air control. And then after that, then we can apply our comfort board to the interior walls. So we'll have the continuity of that Stego up the wall, 8 inches, taped and sealed, no issue there, and we'll have the thermal break when we go to pour that concrete slab. Now let's talk about air. I mentioned it briefly with regard to the Stego, but certainly if you've heard Steve Basic say, if you don't think concrete's a good air barrier, go ahead and put your lips against it and blow. It's a poor use of time and a good joke by Steve. We will have obviously the continuity of air control in our exterior foundation wall, but we have to connect it to our wood framing. Our floor system will frame on top of wall, and we're going to connect it there with a sill tape, again from our friends at PolyGuard. It's part of their term series. It's a termite barrier. We are in termite country here in the Midwest, in Missouri where we're at now, and we want to make sure and have that separation, but we still have to control for air. So that sill termination to stop the termites from making their way up is great to seal to the top of the concrete, but we still need to make an airtight connection from that point to our wood framing. And for that, we always choose Big Stretch. Now, Steve's details include a lot of Trimco acoustical sealant. That's a really great product. I don't have anything bad to say about it, except it is awfully messy. And we don't like a mess. What we like is the 200% elongation we get out of Big Stretch in a condition that's not going to be challenged with easy cleanup and a 30-ounce tube. So we'll be moving with 2 beads of Big Stretch. It's another Steve Basic detail on the sill gasket, and then we'll connect our plate down. So that will have our air control continuity from our foundation wall into our wood structure, and then from there up, it's all SIPs. Now, once we do the floor diaphragm in that future episode, we're going to start talking about all the air and water control above grade, but this episode's really about our below grade solutions. All right, for our Prairie Sun Timber series, we're not doing anything groundbreaking on the below grade walls. This is your typical 7.5 inch thick, poured in place, concrete foundation wall on an 8x16 cast in place footing. And what we're really talking about at this point is just how we got from dirt to this. So if you're not familiar with the traditional residential foundation, what we're talking about is a 16-inch wide by 8-inch deep concrete footing placed on undisturbed soil. So we've excavated down below grade to below our basement slab height that we would walk on and place this footing. That wider base then allows for us to place concrete forms on either side of a 7.5 inch wall, which we then tie rebar and all through, which of course you got to have rebar in that's reinforcing steel in the footing as well per the engineer's schedule. But you tie all the steel inside of the forms, pour the concrete, strip the forms, and now you have this nice, sturdy, forever wall. And this is really how we begin every project. We excavate after surveying, we place the footing, cast the wall, and we're really about ready to move forward, building on top. But first, we have to manage for water. What we chose to do on this project was Polyguard system. Polyguard is one of our preferred manufacturers for the same reason that we work with Huber and Rockwool and all these other great products. They have a system. It's not a one-off. You're not getting one piece of the puzzle. You're getting things that'll work together. Just like our Stego has a tack tape and a seam tape, we have Polywall providing a wall coating, and then they have this great Flow 10 product. And what this is your traditional drainage board. It's a dimple mat, but it has this fantastic fabric facer on it so that you don't get integration of the soils and fines to block that drainage. And that also is extended 4 inches above so that you can easily lap the surface. And this just installs with an actuated fastener and a washer head. And then there's a termination bar at the top that gets sealed with their Mastic 650. So the Polyguard system is going to allow any water that would migrate against our foundation wall, any hydrostatic pressure, to be relieved. It'll flow through the dimple board, run down to the drain tile, and then we can carry it to the sump and discharge it, or it can drain to daylight. We have both options on this house. So it's belt and suspenders, traditional contractor stuff, right? With Polyguard, we have all of our exterior water management covered, and now we can move on with the more important matters of building. So now we can show you our Polyguard system in place. Again, what we're doing here is managing for any exterior rainwater and runoff or groundwater that could potentially impact our build. You can see we have the Flow 15 product. It's properly shingle lapped with the fabric facer to keep any of the fines from integrating within the drainage board that would block up that potential drainage. All these fasteners have been installed to keep this in place during backfill. And then of course we've tied in a robust PVC drain for our walkout because this location will have a very large stone retaining wall. So as with everything, we want to make sure that we're top sealed. The Polyguard folks provide us a termination bar at the top. We then seal that to the wall with the Mastic 650, and that keeps any water that would flow down the top edge of the wall from getting behind the drainage board and challenging the concrete wall behind. So this is our system for foundation drainage. Now that we've got water down and away, well, actually we've got it down, then it gets into the pipe, and then we take it away. But once we've got that managed, we can move on to backfill and then building up from here. Okay, we've talked about how this project is different. There's a lot of new things on our Prairie Sun Timber series, new to us, things that we don't normally work with. Certainly timber framing is an old world, tried and true method for providing a beautiful structure that we really want to highlight with all the vaulted ceilings and exposed timber. That's going to be an easy one to see. But what you won't see, after the SIPs land, we've got to do some structural connections that are normally handled in stick framing very differently. We won't have access to run our anchor bolts up through into our secondary bottom plate. Obviously, these anchor bolts are going to hold down a single sill plate. We'll slide the SIP panel over that and side nail for shear, but we need some additional hold downs because of the unique structural properties of the SIP. And that's where Simpson comes in. We've got these hold downs that were designed into the plan by the structural engineer to make sure that we're dealing with both shear and uplift. Certainly as a hold down, we're talking about uplift. This is the Simpson STH-D14RU. And this is actually cast into the foundation so that every single one of these holes gets filled with a nail that makes a structural connection to our SIP panels at all these key points on the house. So here at the stair column, there'll be a nice, full height stair behind me that gets from the finished basement all the way up into the main level. This is a high wall condition, and we need obviously additional strength to make sure that our SIPS panels are performing as the structure needs to perform to distribute loads, carry everything, and make sure that we keep things from moving around. So that's what these hold downs are for. And talking about them now makes a lot of sense because once we install the SIP, we're going to coat all this with Proseco, and it's going to end up covered up. You won't be able to see them again. So that's why I wanted to talk to you about them now. The placement is very intentional. This isn't something that you do willy-nilly. These straps have to be at the precise location to provide that structural strength and integrity. Out here getting ready to finish up our underslab plumbing, place some crushed stone, and then we'll start placing our underslab insulation. We do an awful lot of work with Rockwool, and the reason that we do is it's basically spun almost like cotton candy, but instead of being long strands of sugar fibers, it's strands of basalt, literally rock from the earth. It's a mineral, it's a stone wool product. So what we've got here is a stack of 15 3-inch thick sheets on each of these pallets. And the plan is, once the plumbing is done and approved by our local jurisdiction, we'll go ahead and take all that crushed stone and level off to the top of the footing. Then we have a nice level flat deck to place 3 inches or R12 of insulation and provide a thermal break from the slab to the footing. And we'll run this all the way up to the wall. And then we'll go ahead and place our Stego vapor barrier over the top of that. That's a Stego 10 mil Stego home product. And we'll tack tape that at the edge, bending it up the wall a good 8 inches, and then seal the top edge before we install 3 inches of comfort board on the walls. So we're going to basically create a nice insulated bathtub where all the thermal energy, the warmth that we will be putting into this basement to keep our occupants comfortable, that won't be lost to the earth, which is typically 55 degrees. So insulating the basement, insulating under the slab is great, but if you don't have continuity between the two, you really shortchange your result. I think it's between 25 and 40% of heat loss to that earth at the outside 4 foot of the slab. And you can see we're not super wide, 20, 26 feet in places. So having that cold creeping in would really be a comfort compromise that we don't want to make. So providing continuity of thermal control under the slab, up the walls, and then up into our SIPS panel and over the roof is going to provide an incredibly comfortable and efficient home for this client. So you can hear the raindrops falling all over my comfort board. And it's made of rocks, so I don't care. That moisture is going to migrate down through the board, through the crushed stone, and into the earth. And this might be an application where I actually get to benefit from solar vapor drive, because when the sun comes up and heats up the tops of these boards, that moisture is going to drive down faster and move into the soil below what doesn't evaporate off the top. So it's just not a concern. All right, you can see we've wrapped up our underslab installation with Rockwool Comfort Board 80. This is the 3-inch product for R12 of thermal resistance to heat loss to the earth. And it didn't take us but a half a day with 4 guys working through the rain. We took a couple breaks when it was really storming. But it's as simple as cutting it about a 1/4 inch long, cuts with a saw, very simple, very easy. You can use a straight edge to keep your cuts nice. And then that board that you're using as a straight edge is a really great way to distribute your load, to push down those edges for that tight fit. Just lay it across that edge right against the foundation wall, a foot down the middle, or if you need to, you can treat it like subfloor, get it with a sledge. So all those things that we did, we wrapped up in a half day, and this will serve this home forever. As long as there's a house here, we will be thermally broken from the earth to the basement slab to add comfort for the homeowners for generations, we hope. Now there's more to do here. Obviously we've got to lay out the stego, get it 8 inches up the wall and sealed off. And then our next move is to go ahead and lay out our beams. Every beam and column location has to have that point load carried down through the columns into the footings that we've covered up now. So we'll lay those out, mark them, cut them out, and then tape the stego down into that pocket that we cut away in the Rockwool, because the Rockwool is not ideal for compression. It can handle a lot. Obviously we walked around on it in the rain with no ill effects, but the structural load of the house, you don't want to take any chances. You want a concrete to steel connection on those columns. So we'll actually cut the Rockwool away in about a 6-inch diameter for those columns to sit all the way down, for the concrete to go all the way down into those pockets over the stego, which we'll tape around and we'll show you that too. But then we have a concrete to concrete connection so that we have all the compressive strength that we would need per the engineer's specs. So that's our next move. Come back with us when we're doing the stego on the walls, and then we'll go ahead and do the Comfort Board 80 on the walls over the top of that to break that slab edge from the foundation, and we'll do something special here at the back wall. This is all part of our below grade solutions. We're managing water, we're going to manage radon, we're obviously always managing for air, but we talked about our water management on the exterior. We want to talk about water vapor on the interior. Now, when we installed our Rockwool Comfort Board for our underslab insulation, one of the things that happened, unfortunately for us, is it was raining. Now, it was a little cooler. It wasn't as hot as it is today without the sun beating down on us, but it did get our comfort board all wet. Now, I mentioned we're not worried about that because it's a durable product made from rocks and it's free draining. So the water is just going to migrate through and drain through the crushed stone base. But today, we're installing our vapor barrier over top of that. And so we want to make sure that our vapor is only going down and away, not up into the slab. So let's talk about Stego Home for a second. What we've got here on our project is a ladder access, or we walk through the mud. So we're going up and down ladders in and out of houses. We really like that Stego Home is available in this 12-foot roll that I can throw over my shoulder and carry into the house, only 3 feet wide. Now, if you watched our barn dominium footage, you notice that we use the Stego wrap. Now, these are both a 10 mil product. They both serve the same purpose for us. They seal the vapor out of the system, and they also prevent soil gases from infiltrating into the living space when we properly tape and seal the edges. So both products, essentially the same purpose, but what you're seeing here is that I can easily carry it in and out of the house. So this 12-foot roll, very easy to manage. The 14-foot roll of Stego wrap was great on the barn because we were laying it out of the back of the truck and then rolling it out. It's a 2-man lift versus a 1-man lift. Very mobile up and down a ladder, a little bit more challenging with that big 8-foot roll. So that's the 2 different products that you're going to see on our project. We had some leftover wrap from the barn, and so we ordered some home for the rest, knowing we'd be up and down the ladder. So installation of this is very simple. Stego, like most of the products that we use, they're providing a system. It's not just a piece of vapor barrier, and it's not anything like the 6 mil poly that you're used to seeing underneath your typical floor pour that gets punctured from guys walking around on it and dragging steel. This is a much more robust at the 10 mil thickness, but also the resins they use are superior, so they're more elastic. And so we don't really see punctures except where we intentionally cut them. And you can see the elongation rather than tearing around our pipe penetrations. A tiny slit allows us to slide it down, and we can either tape around, or Stego offers a mastic solution. We utilize the Stego tape for most of our penetrations, and we utilize their tack tape for our installation, and we'll show you that as well. But the whole goal for us is to get our underslab insulation covered with the Stego material. We want to bring that material up the wall a good 8 inches. I believe 6 is my minimum code, but that 8-inch rise makes it certain that even if I have a little waver in my cut, I don't have any issues. And then we're going to tape the top as well, not so much to, you know, waste material, because the tack tape is really what's creating the seal. As we press the Stego product into that tack tape, we're getting a continuous seal just by applying a little pressure on the squeegee. And Stego's pretty smart. They put a little bit of a fuzzy fabric on that squeegee so that it doesn't grab on the vapor barrier, because obviously a plastic type resin material will slide freely on that. So if this was just the plastic side, you might occasionally go against the grain to get a bubble out or something and stretch that or compromise that material. By having the fuzzy side, it glides easily and you can really put a lot of pressure on. So that's how we make that continuity of seal around the edge. And then we pull the release paper off of that, or release tape. It's a plastic. Press our Stego home product into that tack tape, and now we have the seal as soon as we apply the pressure. We do that with some fancy geometry at the corners, and then we use the tack tape to make up our seams. We use the Stego tape to make up our seams, and then also detail around our pipe penetrations. Now you can see here we did a little overcut. We're going to have to use some additional tape here. This one's going to be really easy. I can pretty much tape all the way around because you can see the material stretched. The elastic nature of the Stego home product allowed a small X cut to stretch around, and I can just tape this. But for this, I'm going to have to do some additional taping here. Where the geometry gets a little bit more challenging, that mastic really can be a benefit. So as with anything on our projects, we're always looking for ways to utilize a system of solutions, products that play well together, so there's no chemical incompatibility issues or really warranty concerns. We're going to do this one time ever on any project. I don't know anyone that's excavated out their slab to add a vapor barrier or an insulating layer. I don't think you do either. And so that's why we want to approach this with a level of robust products and detailed installation to make sure that for the life of this home, there's no issues. So because we have a walkout condition here, instead of having a wall that we can apply the Stego tack to, we're actually applying it to the top of the stem wall. So we'll run the Stego out over the stem wall, secure it to the Stego tack, and then we're going to install a form on top of that with a piece of insulation so that when they pour the slab, our 2x6 wall that sits back here with the zip R9 on the exterior will have an additional thermal break between the slab and the studs. So that 3/4 of insulation will give us an additional thermal break on the other side here. And we'll probably end up using some offcuts from our zip product for that. Unfortunately, you can't really wear gloves and work with this stuff very well because it sticks tenaciously to nitrile coated gloves. So that's not a good fit. So what we end up doing is getting sticky fingers and sticky knife points so that we can get it started. This is where the roller comes in handy, or the squeegee. We've been using the Stego squeegee, which I kind of like because the foam or the Velcro on it sticks to my TrueWork pocket. It's kind of a nice bonus. Now that we have it unrolled, we want to make sure that we have 8 inches of coverage up the wall, and then we've got to start cutting out our openings. And this product has enough elasticity that I can usually just do an X cut and stretch it around. This just happens to be a floor drain, so it has a much smaller 2-inch pipe on the bottom than the 5 or 6 inch top. So it doesn't work quite as well, but we'll show you the easy X cut on the other one. For this one, I'm going to do just a horizontal slice, because what we're going to end up doing is detailing it with tape after. So if I stretch it down this side, then I can bring it back over the other. And you can see that's really the difference between this and your typical 6 mil poly that would just tear. So I've torn it here a little bit, but I can use either the Stego mastic or even the tack tape, the regular tape, to seal this back up. And once I tape that there and on around here, when the concrete pours around it and provides positive pressure against that tape, I don't have any concern that we're gonna lose vapor into this location. If I really do have a spot where I'm like, it's not sealing well, I can't get a tight seal with the tape, that's what the mastic is for. So as we work our way across the wall, I wanna make sure that we've accommodated all of our penetrations. And for this, I think rather than trying to slide over the top, which would be possible but difficult, I might just do a slit on either side. The thing is, then I have a taping issue. So it would actually be easier for me to tape it this way because I can access the cut. So now I can run this piece behind, again, still having the opportunity to tape it. But because this pipe is right up against the wall, if I make the slice dead behind the pipe, now I don't have a good way to access it. Whereas if I do it this way, I can seal the majority of my tape joint all on this side. Much easier to do. So once this is in place, my only 2 pipe penetrations on this run, now I'm going to go ahead and apply the Stego tack. So I want to start at the bottom, make sure that I'm tight, and then stand it up. Because again, I do not want, for any reason, my insulation to be pulled out at the bottom. And it's got a high initial tack, but if you need to reset it, if you make an error, you can, if you're swift about it. And then this is where the fabric side comes in. Once you do have it set, that fabric side won't tear into the resin of the Stego itself. And as long as I have continuity visible on my tape all the way, I have full confidence that we've achieved the vapor barrier and soil gas protection that we have to provide. And you can see that now I can tape this top edge, but this is not my first line of defense. The tape at the leading edge is just to hold it up out of the way and get that 8 inches up before I apply my sidewall insulation, more Comfort Board 80. But that is well sealed and I can move on down the line. So we're still tight to the walls. With this fold, my interior insulation can still lay flat. So I'll go ahead and bring that top tape across. This is one of those spots where I'll use a couple little pieces to get things set before I really start messing with stuff. So I want to make sure that stays tight in the corner. And again, that bottom corner is not really as critical because there's nowhere it can go. Once I seal this across the top, I'm done. I have continuity achieved at the stego tack. This is really all just extra. It's just about keeping any water that might rush down the walls in a heavy rain from getting into this joint and causing this stego tack to let go. It's a great adhesive, but it's not designed to hold back several inches of water column. That's just not realistic. And now I need to trace down the whole rest of the wall. So I'm going to pull this off. Make sure that we have great adhesion all the way tight to the corner. And this, what inlet it could be, is folded back down and captured. So it can only get to there. So the stego seam tape isn't rated to hold against concrete. But let's go ahead and just do a little test here. So yeah, it probably isn't a perfect seal the way the tack tape is, but it's ripping the face of the curing compound and some concrete off. So it's adequate to hold this in place while we're waiting for our concrete pour. We're not at all at risk here, at all. We're getting ready to set our mud sill. Now, typically, you've seen our details in the past. They involve a basic sill gasket, just a foam sill seal that is really meant as a capillary break between the concrete and the wood plate. We usually adhere that with a couple beads of big stretch from Sashco underneath, and then one bead on top around the bolt line to make sure we have a continuity of air control. And that's a Steve Basic detail that we've been using for years. We're doing something a little different on this project. We're out here in the prairie, and there's just not too many limitations on birds and pests and insects. So we're a little bit more concerned about termites. So since we're working with Polyguard on our below grade drainage solutions, we're also working with Polyguard on this termite barrier product line. Now, we would ordinarily talk to Polyguard about exterior water management. You've known them from all the stuff that Matt's been doing over the years, but the Polyguard product line is actually quite a bit more than that. And so we were excited to discover this term product line that includes not just the sill gasket, but also a number of sealants and a particulate barrier that we'll get into later. But to get this thing started, what we're looking at is our standard square everything up, snap your lines. We're gonna go ahead and apply a bead of big stretch on the inside, underneath, well, I should say on the inside of the bolt line, underneath the gasket, to make sure that we have a way to make up for the irregularities in our top of wall. Even though this is a thick, I think it's a 68 mil thick gasket, it's not gonna be able to make up for really poor concrete, and we just wanna be doubly sure that we have our continuity of air control. So we're gonna apply a bead of big stretch on the inside, then we'll apply our Polyguard term barrier system gasket tape on the top of that, overhanging the edge of the foundation just a little bit. And then before we set our plate, we'll do a big stretch seal along the outside of the bolt line to make sure that we have continuity of air control, so that when we move up with our SIPs and our Proseco sealant gets applied, we'll have full continuity of air control across the exterior all the way to the concrete foundation wall. So that pretty well wraps us up for our first episode of the Prairie Sun Timber series. Of course, we've covered our below grade water management strategy with the Polyflow 10, the dimple mat, basically getting all of our water from the site drained down and away. And that is a really good starting point when we start talking about control layers. We always start with water, and then we move very quickly into air sealing details, our big stretch under the mud sill, and then obviously the sill tape itself being part of that solution. And then we went into our thermal and vapor control, the vapor control being our stego that we showed under slab, and our Rockwool comfort board to insulate from the earth below the slab, as well as at the sidewall of the foundation to keep that thermal bridge broken and our clients comfortable inside. So that's episode 1, seen through the lens of the control layers. Why don't we go ahead and tease a little bit what we've got coming at you? Because in episode 2, we're gonna start talking about what's above grade and these SIPS panels and the big, beautiful timbers that are gonna make up the personality of this home going forward. So come back and check us out for episode 2 here at the Prairie Sun and Timber series.